Okay, so we're going to be working on evaluating functions today, and we're going to have to make use of our Desmos scientific calculator. So why don't you go ahead and get that open? Um, we need that so that we can do some evaluation and fill in our tables here. So let's go ahead and start with developing our table. So we've got this function y equals negative 3x plus 4. And remember, y equals and f of x are the same thing. So these two could be written the same way. F of x equals negative 3x plus 4. And I'm going to substitute in negative 2, negative 1, 0, 1, and 2 and find my numbers so I can fill in my table, look for some patterns. This is linear, so I know I'm going to be able to come up with my slope and my y-intercept. So let's go ahead and start. So remember, we're substituting in for our x. So I'm going to start with negative 3. And my parenthesis, the first number I'm going to put in is negative 2. And I am adding 4. So my first answer is a 10. And I'm going to change that negative 2 to a negative 1. And it gives me a 7. And if I change the negative 1 to a 0, it gives me a 4. Now, I want you to take a look at this real quick and tell me if you see a pattern, because we're going from 10 to 7, 7 to 4. Pretty sure we're subtracting 3. So 4 minus 3 would be 1. 1 minus 3. If I need help with that one, I can do 1 minus 3 is going to give me negative 2. So this pattern holds. So my pattern of the y is negative 3. The pattern of the x, that's positive 1. Now, if you remember, our slope can come from our table, and it's the change of the y over the change of the x. So my slope is going to be negative 3 over 1, which also comes from my equation. The y-intercept was positive 4. Okay, y-intercept is positive 4. Let's go ahead and graph these points. So negative 2, 10. So negative 2 on the x, 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And negative 1, 7, and 1 to the left, 1, 2, 3, 4, 5, 6, 7, 0, 4, puts me here, 1, 1, and 2, negative 2 is going to put me here. And this is obviously a line, okay? It's obviously a line. Okay, so let's spend our time talking about function notation today, the difference between standard notation, function notation, and how we actually evaluate functions, because they evaluate in a couple different ways. We looked at a graph yesterday, trying to evaluate the graph. Today we're going to work on some of the graphs, but we're also going to work on evaluating a function and then solving a function. Okay, so the difference between standard notation and function notation is just simply what's on the left side. Okay, what's on the left side? So in standard notation, I have y equals. Function notation, we talked about, is read f of x or g of y, depending on the variables. But it is literally the same thing. It's just fancy y equals. Okay, but it is used a lot with different types of functions. And since we're moving into looking at other functions, quadratics, polynomials, exponentials, it's important that we understand how they work. Okay, so when we develop a function, what we're really doing is answering the questions, find f of x when x equals 5. Only thing we're finding, find f of negative 2. Okay, find f of negative 2. So I'm going to go ahead and pull my calculator back up, and we're going to see if we can do this. So if I need to fill in my table, I start with my negative 3, and I have my parenthesis, and I throw in the negative 2, parenthesis plus 2. I see the value of negative 2 is 8. Okay, so that was f of negative 2. That answer is 8. Okay, I'm just substituting in for the x. So negative 3, let's throw in the negative 1. And we won't even use our calculator this time. Negative 3 times negative 1, that's 3. 3 plus 2 is 5. And we can do the same thing with a 0. Negative 3 times 0 is 0. 0 plus 2 is 2. And I can go back and use my calculator. Make that a 1. Negative 3 times 1 plus 2 is negative 1. And change the 1 to a 2 to get my last value. It gives me a negative 4. Okay, so when I'm asking you find f of x when x equals 5, or I'm asking for f of 5, either the way, what I want to know if I was making a table and that number was a 5, what would the answer be? So it's just substitution. So I'm going to take negative 3 times the 5 plus the 2. Well, that's negative 15 plus 2, which is negative 13. So the answer is negative 13. Same process if I want to find f of negative 4, which is what this is. So negative 3 times the negative 4 plus 2. Negative 3 times 4 is 12. 12 plus 2 is 14. And function notation, the way that we normally write it, looks like this. So f of negative 4 equals 14 instead of x equals or y equals. Okay, we start with whatever number we substituted in. That is function notation. Okay, so let's keep going. And let's look at our next problem. All right, so we've got another graph here where we have g of x and we have x and y. So same process. Okay, we're going to just substitute in. So let's use our calculator this time because we have bigger numbers. So 8 parentheses, and I'm going to start with negative 2 parentheses minus 11. So my first answer is negative 27. And I'm going to go over here and I'm going to change that to a negative 1. And it gives me a negative 19. And if I change it to a 0, it's going to be a negative 11. If I change it to a 1, I'm going to get negative 3. And if I change it to a 2, it's going to give me a 5. Okay, so I just filled in that table. So again, they want g of 5 and g of 4, which means they want me to tell me if I put a 4 here, what's the answer? If I put a 5 here, what's the answer? Well, all we're going to do is substitute. So I'm substituting in for the x. So the 5 is going to go in for the x. The math happens on the right side. So 8 times 5, well, that's easy. That's 40. 40 minus 11. I can do that one over here if I want to. 40 minus 11. Oops, that's 40 minus 1. 40 minus 11 gives me 29. Okay, so same thing. I'm going to substitute in for the x. The 4. 8 times 4 is 32. 32 minus 11 is going to give me 23. And again, we normally write function notation starting out with whatever number I'm substituting in. So that I can say that's g of 5. Okay, that is g of 5. Okay, so let's see if we can work backwards this time. So notice this time, instead of having the number inside the parentheses, which is the x value, I'm actually telling you that f of x equals 2. Okay, I'm telling you that f of x equals 2, which means we're substituting in to a different location. So f of x is actually here, so the 2 has to go here. So I have 2 equals 2x plus 12. Well, that means I'm solving for x. Okay, that means I'm solving for x. So to solve for x, I know I need to subtract my 12. This is going to go away. 2 minus 12 is negative 10. And I divide by 2. X is going to equal negative 5. So there is my answer when I'm looking for f of x equals 2. Okay, let's try f of x equals 20. So again, it's going to go on the left-hand side, not the right-hand side. So 20 equals 2x plus 12. Now, if I don't like what this looks like, I can certainly flip it and write 2x plus 12 equals 20 and just flip these guys. Okay, and thinking back to solving equations, I know this is times 2 plus 12, so I'm going to subtract 12. 2x is 8, dividing by 2, x is 4. X is 4. Okay, so let's do a few of these that have both types so we can kind of see the difference again. And don't forget, we might actually see some with powers. So we'll make sure and talk about how we handle x squared before we're done today. So this one says g of x equals negative 5x plus 2. And it wants me to find g of negative 1. So this is telling me that is x. So it has to go in where x is. So the first substitution is going to happen on the right-hand side. Negative 5 times negative 1 is positive 5. 5 plus 2 is 7. So my answer, I started with g of negative 1. The answer is 7. So I'm going to write it in function notation just like that. Okay, same thing with this one. G of 0. It's saying let x equal 0. So negative 5. I'm going to put in the 0. Well, that's 0. 0 plus 2 is 2. So my answer, g of 0, is 2. And here's the opposite. F of x equals 18. That means it's going to go on the left-hand side. So 18 equals 4x minus 2. Solving this, I see it's times 4 minus 2. So the opposite would be plus 2, divide 4. So I'm going to add 2. 18 plus 2 is 20. Drop my 4x, divide by 4. I come up with x equals 5. And that one's finished. And same thing with this one. Negative 2 equals 4x minus 2. I am adding 2. 4x equals 0. Divide by 4. X is going to equal 0. Okay, let's talk real quickly about how we handle powers when we have a problem like this one. So let's say f of y equals 3y squared plus 2y plus 1. And I want to know what f of 2 is. Okay, so this is saying let y equal 2. Notice how there's two variables here. So that means I'm going to substitute twice. So in here and in here goes the 2. Okay, so this is a very good calculator problem, and I'm going to put it in just like I see it. So I'm going to start with a 3, a parenthesis, a 2, a parenthesis, and then I have to use my power, and I see I have a squared button here. So I'm going to go ahead and hit the squared button, and I'm going to move over, and then plus 2, parenthesis 2, and move over, and plus 1. And I've got my answer, which is 17. And I can do the same thing. Let's say I want to do f of negative 3. So I'm going to put in a negative 3. And again, it's real easy just to click inside of the equation that you've already got started. Backspace, change that to a negative 3. Go to the 2. Backspace, change that to a negative 3. And I see my answer is 22. Okay, so don't panic if they give you powers. It's the same thing. You just need to substitute every single time you see a variable. Okay, see what you can do with your homework today. We're going to practice more of this tomorrow, and let us know if you're stuck.